Hello everyone. I am so sorry I am not in class today, but I wanted to make a little recording for you about how we would go about solving rational inequalities. This is very, very similar to what we did when we solved polynomial inequalities. We're going to follow the same steps. We're going to look at the function. We're going to create the appropriate sign diagram. And from there, we'll be able to determine where functions are greater than or equal to particular values. So let's just start by looking at a basic rational function. So we've got f of x equals x plus 3 times x minus 5 all over 2x minus 1. And the question is to determine the real number values of x that cause f of x to be 0, undefined, positive, and negative. Well, first of all, let's figure out where it's going to be 0. Well, 0 is when we're going to have roots. To find the zeros, we are going to look at what makes the numerator 0. In this case, that's going to be when x is negative 3 and when x is 5. Where it's undefined is where my denominator is going to be 0. So if we set the denominator equal to 0, we'll figure out the equation of the asymptote, and that's going to be at x is 1/2. Just like we normally do, we create a sign diagram from this information. So as you can see, we've got ourselves a sign diagram right over here. I put on the 2 zeros along with the asymptote. Don't forget, make your asymptotes little dashy lines because it's going to become really important in just a little bit. And go ahead, you would pick some test values. I picked -4, plugged it into my original equation. That was negative. Since all of my multiplicities are odd, we know that it's going to alternate. So here we've got my sign diagram. So looking at my sign diagram, where it's positive is between -3 and 1/2, and then again from 5 to infinity. Notice when I write it, I don't include that -3. I don't include that 5 because I asked where it's positive, not where it's equal to 0. Same idea works when we're looking at the negatives. It's going to be from -infinity to -3, and again from 1/2 to 5. When we're looking at solving rational inequalities, we've got a couple of options. One option is to solve it graphically. The other is to solve it algebraically. So let's start with solving it graphically. When we're solving it graphically, we basically are going to go through our 7 steps and we're going to create a graph. I'm going to do a slightly abbreviated version. You're welcome to pause this recording, go through, try graphing this, and see if you get the same answers I do. So first of all, if we're going to figure out our vertical asymptotes, well, that's going to be what makes the denominator 0. So in this case, it's going to be 2 or -2. Horizontal asymptote, well, since the degree of my numerator is less than the degree of my denominator, we know we're going to have a horizontal asymptote, and that horizontal asymptote is going to be at y equals 0. To figure out my y-intercept, I'm going to plug in 0 for x. So if I substitute 0 in for x in the numerator and 0 in for x in the denominator, I'm going to end up with a value of 1/4. So my y-intercept is going to be at 0, 1/4. For my x-intercept, I need to figure out what's going to make that numerator 0. So if I set my numerator equal to 0, I'm going to find that my x-intercept is at 1, 0. So just like we've done in the past, we can create a sign diagram using the vertical asymptotes and the x-intercept. Now we don't need to do the y-intercept or the horizontal asymptotes because we only put x values onto that sign diagram. I'm going to skip the sign diagram for now and go straight to the graph. So here we've got our lovely graph. As we look at this, if we want to figure out where it's greater than or equal to 0, we're trying to figure out where the graph is above the y-axis. Looking at the graph, it's above the y-axis from -2 up until 1, and then again from 2 to infinity. Now notice how I'm going to write this. When I'm writing it, it's from -2, and I don't include that -2 because it's an asymptote, because it will never ever get there. But I am going to include that 1 because I said greater than or equal to. If I would have said just greater than, I would not have included that 1. Then again, we're going to pick up again where it's above that y-axis. That's going to be from 2 all the way up to infinity. Again, I don't include that 2 because it's an asymptote. Okay, let's make this one step harder. Instead of having something that we can kind of just look at, let's go ahead and solve it algebraically. So if we're going to solve it algebraically, first thing I'm going to want to do is start factoring. So first things first, factor numerator and denominator. And I'm going to do this in steps. First thing I'm going to factor out is the 3x out of the numerator and the x out of the denominator. Looking at this, this is not fully factored yet. So I'm going to need to keep factoring. So I continue on. And that numerator breaks down into 3x times x minus 2 times x plus 2, and the denominator factors to x times x minus 3 times x minus 1. Now notice I've got a common factor. Since I've got that common factor, I'm going to go ahead and rewrite it so that it is in lowest terms. So written in lowest terms, I'm going to have 3 times x minus 2 times x plus 2 over x minus 3 times x minus 1, and all of that still needs to be greater than 0. So, picking right up where we left off, from here I can create a sign diagram. I'm going to need to figure out where my asymptotes are going to be. Well, that's going to be when x is 3 and x is 1. And I also need to figure out my roots. Well, that's going to be wherever I would have the numerator equal to 0. So that's going to be at 2 and at negative 2. So here's my lovely little sign diagram. Notice I've got my asymptotes, 1 and 3. I've got my roots at negative 2 and 2. I picked a test value of negative 3, substituted it in, and it was positive. And since all of my multiplicities are odd, it's just going to alternate. And so now our question is, where is it greater than 0? Well, it's greater than 0 when the values are positive. So it's going to be from negative infinity to negative 2. And it's going to be again from 1 to 2. And it's going to be again from 3 up to infinity. Now, am I going to include negative 2? Or am I going to include 1 and 2? Or am I going to include 3? What do you think? Good. You're right. We're not going to include them because it wasn't greater than or equal to. It was just greater than. So here's my final answer. Okay. Let's do one more example. This time, instead of it being greater than or less than 0, this time it's it's going to be greater than or less than a number. So in this case, we've got 3x squared plus 13x plus 9 over the quantity x plus 2 squared is less than or equal to 3. So if we're going to solve this algebraically, the first thing I'm going to want to do is bring the 3 over so it's with 0. So I just subtracted 3 from both sides. Next, in order to combine those terms, I'm going to need a common denominator. So the logical common denominator is going to be x plus 2 quantity squared. Once I've got a common denominator, I'm going to go through a simplification process. And I'm going to do it in a couple of steps. So the first thing I'm going to do is I'm going to expand that x plus 2 squared in the numerator. So I've got x squared plus 4x plus 4. Next, I'm going to go ahead and I'm going to distribute that 3 in. So when I distribute that 3 in, I've got 3x squared plus 12x plus 12. And now we've got it in a form that makes it a little bit easier to work with. Now I can just combine my like terms. So the first thing I'm going to do, well, 3x squared minus 3x squared, well, that's 0. 13x minus 12x, 1x. 9 minus 12, well, that's going to be a negative 3, all over x plus 2 quantity squared. Ta-da! So now this is in a form where we can actually use something with it. So again, I'm going to create a sign diagram for this simplified rational function. So I'm going to figure out my asymptotes and my x-intercepts. So looking at the numerator, what's going to make the numerator 0? Well, that's going to be 3. And where's my asymptote going to be? It's going to be at x is negative 2. Now notice when I create my sign diagram that on either side of the asymptote, it's negative. This is because we had that even multiplicity. So when I plugged in my test value of negative 3 and simplified, if I plugged in negative 3, I got a negative value. And since we've got that even multiplicity, we know on both sides it's going to tend towards negative infinity. Then because the numerator has an odd multiplicity, we know it's going to switch signs. So if we want to solve where x minus 3 over the quantity x plus 2 squared is less than or equal to 0, well, it's basically anything from negative infinity up to 3. However, we've got that asymptote, so you have to take that into account. So our solution is going to be negative infinity to negative 2, or negative 2 up to 3. That 3 is included because I said less than or equal to. But we have to take into account the fact that we have that asymptote because it's that restriction. It can never actually be there. Again, I'm really sorry I had to miss you in class today, and I hope you have a wonderful day with Mrs. Oliver. I will see you on Monday. If you have any questions between now and Monday, feel free to email me or come in and see me on Friday. And as always, if you've got any questions for your upcoming quiz, let me know. I hope you have a wonderful day, my darlings. Bye.